today's video, we will explore two classic examples of recursion, Fibonacci sequence and factorials. So let's get started.
well-known sequence in which each term can be found by adding the preceding two terms. इसमें हमारे पास हर term preceding two terms add करने से find की जाती है. Like if we have 0, 1, 1, 2, 3, which is 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, and 3 plus 2, 5, 5 plus 3, it is 8, and 8 plus 5, 13, and up to so on. This is a Fibonacci sequence. For that, we see that our first term is 0, second is 1, and if we continue on, we have this formula of Fibonacci sequence. Let's see. अगर हम 3 से start करते हैं, we have f3. 3 minus 1 is 2, plus 3 minus 2 is 1. That is previous two terms. f2 is 1 plus 0. It will give us 1. So third term is also 1. f4 is f3 plus f2 उससे मज़ीद पिछली हो, and we have 3 is 1 and 2 is 1, which is 2. If we see f5, we have f4 plus f3, which is 2 plus 1, 3. We go for f6, we have f5 plus f4, which is 3 plus 2, and which is 5, and it will continue so on. That's the essence of recursion, using output of earlier steps to generate the later steps.
So let's see the real life examples of Fibonacci sequence. Sequences occur naturally in number of petals, pine cones, and patterns of chambers in nautilus shells. Their growth follows Fibonacci sequence, a famous sequence in which each term can be found by adding the preceding two terms. Some other examples are arrangements of tree branches and leaves, and patterns of flowers like calla lilies having one petal, black-eyed Suzanne with 13 petals, and daisies ranging from 21 to 34 petals.
Fibonacci sequence is not only sequence defined recursively, there is also an important one called factorial sequence. Now you might be wondering what happens. So for that reason we have to understand factorial notation. It is a product of consecutive positive integers. Like 1 factorial is 1. If we have 4, that simply means 4 multiplied by 3 multiplied by 2 multiplied by 1. So this is 4 factorial. Similarly, 7th factorial is 7 times 6 times 5 times 4 times 3 times 2 times and 1. Another example that we can take is 3 factorial. That simply means 3 times 2 times 1, which is 6. So what does n factorial means? A mathematical operation that can be defined using a recursive formula. Again, it depends on the previous terms. If we have n, that means n उससे term and up to so on, it will reduce to 1. If we have n plus 1, that means it is one term more, and that means it comes after n. So n plus 1 and n minus 1. Now you might be wondering what happens if n equals to 0 factorial. Is it 0 or what? But no. There is a catch by definition, and it is a special case that 0 factorial is 1. Even though multiplying no numbers together might seem like it should be 0, the value of 0 factorial is set to 1 to make formulas and equations work smoothly in all cases. So, for that reason, it is set to 1. Speaking of formulas, factorials are everywhere in math, especially in areas like combinatorics, where we calculate things like permutations and combinations.